Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amirul Haziq bin Basri. My ID number is 532132230008. So today I will demonstrate Arduino of the temperature sensing by using LM35, a switch, an LED, and a push button by using milis. So this is the circuit that I have completed for the temperature sensing. This one is the LM35. This one is a push button resistor of 10k ohm and LED. This one is resistor 220 ohm and this one is a buzzer, passive buzzer. So how does this circuit work? So basically, when the LM35, there is the temperature sensor sensing 30 degrees Celsius or above that, it will send the signal to the Arduino and then it will feed back to the output to the LED, this one, LED, and the buzzer. When the temperature sensor exceed the 30 degrees Celsius, so the LED will turn on and the buzzer will make a sound like a buzzing. So what is the function of the push button? So the function of push button is to enable and disable the monitoring temperature at the serial monitor on our Arduino code. So when you push this one, the monitoring is enabled and now it works because of the connection is not to the ground anymore. So the power from the 5V will connect and round to the circuit. So right now I will show you how the circuit works. So for this Arduino, I set the code to the 30 degrees Celsius. So when the LM sensor temperature sensor, when it sends 30 degrees Celsius above, so it will send signal to the Arduino and then it will feed back to the LED and the buzzer. So the LED will be turned on and the buzzer also will be buzzing and making a sound. So the push button, the function of the push button is to disable and enable the monitoring temperature. So right now, as you can see, the monitoring is disabled right now. So I will enable the monitoring and see how it works. So right now you can see the LM temperature sensor is sensing the temperature right now. So when the temperature sensor sensing the 30 degree, as you can see, the LED will turn on. This one, LED will turn on and the buzzer also will buzzing. Like that, as you can see, the LED is turned on and the buzzer is also buzzing. That's how the circuit works. Now I show you what happens when you push button. So as you can see, the circuit is not working. Because why? The connection is now to the ground, so there is no current flowing in the circuit. And as you can see at the serial monitor, the monitoring is disabled. So that's all. So for the first assignment question, the question is how the LM35 sensor converts the temperature into the voltage. So basically, at the heart of the LM35 is a temperature sensitive element based on the properties of the semiconductor junctions, especially diodes or transistor configured to behave like diodes. So fundamental property of a diode is that its forward voltage drop its temperature dependent as the temperature increase. The forward voltage across a diode operated at a constant current decrease at a predictable rate. So conversely, as the temperature decrease, the forward voltage increase. So the LM35 doesn't just rely on a single diode. It contains more complex internal circuit involving multiple transistor and resistor. So this internal circuit is designed to precisely amplify the small change in the voltage caused by the temperature variations in the core sensing element. So the key is the application is to create the linear relationship between the temperature and the output voltage. So it means that for every degree Celsius change in the temperature, the output voltage change by a constant amount. So the LM35 is specially designed to have a linear output scale factor of 10 mV per Celsius. This means for every 1 degree Celsius increase in temperature, the output voltage increased by 10 mV. For every 1 degree Celsius decrease in temperature, the output voltage decreased by 10 mV. So the linear relationship in the Celsius scale is a significant advantage over a sensor calibrated in Kelvin, where a constant offset needs to be subtracted. Okay, so at 0 degree, the LM35, this one, is typically output is 0 millivolt, which is 0. So when it reach 25 degrees Celsius, which is room temperature, this room, so the output voltage is 250 millivolts, which means 25 degrees Celsius multiplied by the 10 millivolt per Celsius. So we get the 250 millivolts. Other example is like 100 Celsius, like a boiling point of water. The output voltage is 1000 millivolt or 1 volt, which means 100 degrees Celsius multiplied by the 10 millivolt over Celsius. So for the negative temperature, depending on the specific variant and circuit configuration, the output voltage can also go negative. So in summary, as an internal semiconductor junction or similar element of the semiconductor junction change its electrical characteristics, voltage drop in response to temperature variations. So internal circuit amplifies this change and linearize the response to ensure a direct proportional relationship with temperature. So the last one is the output is scaled to a convenient linear factor of 10 mV per degree Celsius. Okay, so for the number 2 question is, what is the purpose of the millis function in this project, in this temperature sensor project? So the millis returns the number of milliseconds that have passed since the Arduino board, this one, Arduino board, start to running the program. So it's a non-blocking way to keep track of time, unlike using delay, which pause the entire program execution. So the millis allows other code to run while time is being tracked, which means the millis is continuously tracking the time, and it eventually overflows, reset to 0 after approximately 50 days. For a short to medium duration projects, this isn't a concern. For the assignment question number 3, why do we use an input pull up or pull down resistor with the switch? So the need of the pull up or pull down resistor arises especially when dealing with digital inputs connected to the switch or buttons. So when a switch connected to a microcontroller digital input pin is open, which is not pressed, the input pin is effectively disconnect from any defined voltage level, which is here is 5 volts. Sorry, so this is connected to the 5. So the so in this floating state, the input pin can be susceptible to stray electromagnetic fields, can induce random voltage fluctuations on the pin. So the microcontroller might read the pin as either high or low, seemingly randomly, leading to the unreliable behavior. So what is the solution for the pull up or pull down resistor? So pull up or pull down resistor provide a default non-voltage level to the input pin when the switch is open. So the LM35 sensor itself analog output does not use pull up or pull down resistor. So pull up or pull down resistor are crucial for digital input pins connected to switch or button to prevent floating inputs and ensure reliable detection of the switch state. So for the assignment question number 4, the question is modify the code to blink the LED instead of turning it on continuously when the temperature exceeds 30 degrees Celsius. So when the temperature exceeds 30 degrees Celsius, the LED will turn on blinking instead of turn on continuously. This is the example of the blinking LED by using millis. So for the assignment question number 5, implement an additional feature to display a warning message on the serial monitor when the temperature is high. So as example, in my code, I put it 30 degrees Celsius as the maximum temperature. When it exceeds 30 degrees Celsius, as you can see, the serial monitor printed the warning temperature is too high message. So the warning message appear in the serial monitor. Okay, for the question assignment number 6, how will you modify the code to adjust the temperature threshold dynamically using a potentiometer? So for this question, we add a potentiometer to control the temperature. As right now, you can see at the serial monitor, the current threshold is 10 degrees Celsius. So when I turn this clockwise, so the temperature will rise until the maximum, that is 50 degrees Celsius. So this one is to control the high and low of the temperature. So I pull it back to the minimum temperature. Now I push the button back. So now the temperature is on. When the temperature is too high, then it will print the warning message, and it shows the temperature rising. You see? Okay, for the question number 7, what is the advantage does using millis have over using a delay? So we look into the code again. So we look into the disadvantage of the delay. So the disadvantage of the delay, The drawback of the delay is that it halts the entire program execution for the specified duration. Like if you set the delay to 1000 milliseconds, it will hold the circuit for the 1000 milliseconds. So the microcontroller does absolutely nothing. And then we go into the advantage of the millis. Millis is the returns the number of milliseconds that have passed since the Arduino board start by comparing the current value of the millis to a previously recorded time. So you can determine if a certain interval has elapsed without pausing the program. So because millis doesn't stop the code, you can manage the timing of different events independently in your temperature monitoring. Like example, you can continuously check the button state for enabling and disabling the monitoring, or you can control the LED blinking based on a timer. And also you can update a display if you had one at a different interval. So by using the millis, it makes your project much more responsive to external event. For instance, if you press the enable disable button while a delay is active, the Arduino will recognize the button press until the delay is finished. But with the millis, the button state is checked frequently with the loop, so leading to a more immediate response. So meaning here millis has the fastest or more fast response than delay. So for the assignment number 8, there is modify the code to display the highest recorded temperature since the program start. So we look at the Arduino code. We can see the serial monitor printed the highest recorded temperature. You can see that the highest is 38.09 degrees Celsius. So when that is the highest recorded temperature in this one. Okay, for the question number 9 is to modify the code to include a buzzer. This one, a passive buzzer, to turn on when the temperature is exceed 35 degrees. So when the temperature here, when the temperature sensor sends a 35 degree and above exceed the maximum temperature, so the buzzer will make a sound and buzzing. So I will demonstrate it. First I will enable the monitoring. See, the buzzer is buzzing because the temperature is above 35 degree Celsius. That's how it works for the buzzer. Okay, so for the last question is to modify the code to turn on the LED when the temperature remains above 30 degree for 5 consecutive seconds. So for this mode, I set it to 10 degree to show the example. For the LED will turn on for 5 seconds. So I will demonstrate it right now. Right now it's disabled, so when I push the button, okay, so the temperature is enabled now. So as you can see, the serial temperature, so it's showing the warning temperature continuously high, LED and buzzer are on. So when the maximum temperature is exceed above 30 degree for 5 consecutive seconds, the LED will turn on continuously and the buzzer will buzzing continuously. So that's all for the Arduino project for the temperature for me. So that's all.